Okay, in this video we're going to revisit formal charges. I think in a previous video we talked about how to determine the formal charge based on the number of valence electrons and the lone pairs and the bonding pairs that are connected to that atom. We want a way to more quickly identify the formal charges on carbon, nitrogen, and oxygen, and so we're going to look at these elements more specifically. So when carbon is neutral, it will always have 4 bonds, and this is sort of the basis of why the bond line structures work. But carbon doesn't have to be neutral. When carbon has a positive charge, that's called a carbocation, it'll have a total of 3 bonds and 1 empty orbital. Right, so if I have a carbon atom here, and it doesn't have any lone pairs, if it has 1, 2, 3 bonds, right, 4 valence electrons minus 3 bonds, that's going to be a formal charge of positive 1. And so anytime we see a carbon with a positive charge, we know that it has 3 bonds and no lone pairs. So if we're shown a positive formal charge on this carbon, we know that it must have 1 hydrogen, because it's got to have 3 bonds, because a carbon with a positive formal charge will have 3 bonds and no lone pairs. Because it's showing 2 bonds, I know that there must be 1 hydrogen attached to that carbon. Or if the carbocation is on the end, I know that there must be 2 hydrogens attached to this. Because I'm only showing 1 bond, I know a positive carbon has 3 bonds, no lone pairs, so there's got to be 2 hydrogens attached to that carbon. It turns out when carbon has a negative formal charge, it also has 3 bonds, but it also has a lone pair. And so if you ever see a carbon with a negative charge, I know that it's got 3 bonds and it's got 1 lone pair. Part of the reason we need to remember this is because they won't always show us the lone pairs. If there's a formal charge, they'll always show us the formal charge, but if someone drew this CH3, they might leave off the lone pair. They'd give the negative charge, and they'd know that an organic chemist will know a carbon with a negative charge has 3 bonds and 1 lone pair. And so again, the reason we're kind of talking about this is because we can't always use valence electrons minus balls plus sticks, because they might not show the lone pairs, they might not show the balls. And so we have to be able to interpret, if they tell us what the formal charge is, we have to know how many lone pairs are on that atom. And so the ones that they'll do this to us with are primarily carbon, which we just talked about, oxygen, and nitrogen. And so if you see this, an oxygen with a negative formal charge, in order for this oxygen to have a negative formal charge, it's got 1 bond. So because it has 6 valence electrons, it needs 6 balls plus sticks. So it's got 1 stick, so it needs 6 balls. So we know that it has 3 lone pairs. So anytime you see an oxygen with a negative formal charge, it's always going to have 1 bond with 3 sets of lone pairs. And this is a pattern that you just need to learn to recognize. So as far as oxygen goes, there's essentially 3 bonding patterns that we need to recognize. If we have an oxygen with 1 bond and 3 lone pairs, it will always have a negative charge. Or if it has a negative charge, we know that it has 1 bond with 3 lone pairs. A neutral oxygen will always have 2 bonds and 2 lone pairs. Right, so we've got the bond to the carbon here, the hydrogen, and so I know that it has 2 lone pairs because they're not telling me that it has a charge. Here I've got bonds to 2 carbons. Because they're not telling me it has a charge, I know it has 2 lone pairs. Same thing here. I see 2 bonds, I don't see a charge, I know it has 2 lone pairs. When oxygen has a positive formal charge, it will always have 3 bonds and 1 lone pair. So when I look at this compound, I see, oh, it has a positive charge. I see my 1 bond to the carbon, 2 bonds to the hydrogens. I know it has 1 lone pair, because when oxygen has a positive formal charge, it always has 1, 2, 3 bonds and 1 formal charge. 1, 2, 3 bonds and 1 formal charge. So that's why they can just tell us the formal charge, and they expect us to know. If oxygen has a positive charge, it has 1 formal charge. If oxygen is neutral, it has 2 lone pairs. If oxygen is negative, it has 3 lone pairs. All right, for nitrogen, again, we can recognize these patterns. When nitrogen is neutral, it will always have 3 bonds and 1 lone pair. 3 bonds, 1 lone pair. These guys are all neutral, right? So when they draw this, Right? They're not showing me the lone pairs, but I know nitrogen is neutral, so it must have the one lone pair there. When nitrogen is negative, it's always going to have 2 bonds and 2 lone pairs. So when I see this, oxygen has a negative charge, 2 bonds, I know it has 2 lone pairs. Nitrogen has 2 bonds, I know it has 2 lone pairs. When nitrogen is positive, it will always have 4 bonds and no lone pairs. 4 bonds, no lone pairs. I guess another kind of easy way to do this is, even though they're not showing us the lone pairs, nitrogen and oxygen will both always follow the octet rule. So, when I see this, I see nitrogen has 3 bonds. I know it must have 1 lone pair because it's going to obey the octet rule. When I see this guy, the nitrogen already has 4 bonds, so I know it already has a full octet, so I know that it must have no lone pairs. Same thing is true for oxygen. When I see this, even if you don't have these patterns memorized, that a negative oxygen has 1 bond and 3 lone pairs, I'm only seeing 1 bond, so it must have 3 lone pairs to satisfy the octet rule. Now, the reason I point this out for oxygen and nitrogen is if we go back to carbon, right? Carbon doesn't always follow the octet rule. When we have a carbocation, it is not following the octet rule. But nitrogen and oxygen won't do this. They'll always satisfy the octet rule. It's carbon, when it has a positive charge, where it's going to be not satisfy the octet rule. It only has 6 valence electrons. So if we look at some examples, so if I have this molecule and I want to fill in the lone pairs, right, I have a neutral oxygen and a neutral oxygen. So I know neutral oxygen is going to have 2 bonds and 2 lone pairs. Or using the octet rule, they're only showing me 2 bonds, so these guys must have 2 lone pairs. If I look at this example, this is ozone, right? This oxygen is positive, so I know a positive oxygen is 3 bonds and 1 lone pair. I know a negative oxygen is 1 bond and 3 lone pairs. We can do the same thing for nitrogen. So I know a neutral nitrogen always has 3 bonds and 1 lone pair. This is a positive nitrogen, and so a positive nitrogen should have 4 bonds and no lone pairs. It has 1, 2, 3. The hydrogen makes 4 bonds, so that guy's going to have no lone pairs. I know that a negative nitrogen will always have 2 bonds and 2 lone pairs. So when I see a negative formal charge on the nitrogen, I know he's going to have 2 lone pairs.